number 18. Block P and Q of mass m kg and 5 kg respectively are attached to the ends of a light inextensible string. The string passes over a small smooth pulley which is fixed at the point of a rough inclined plane at 35° to the horizontal. Block P is at rest on the plane and block Q hangs vertically below the pulley. The coefficient of friction between block P and the plane is 0.2. Find the set of values of M for which the two blocks remain at rest. Okay. अच्छा, इसका weight होगा 10m. Like Q का 5 है. 5 mass, so this weight is going to be 50 newtons downwards. There's going to be tension in the upward direction. There's going to be tension in the upward direction here. And then there's going to be mg sine theta, the component of weight parallel to the slope, mg sine theta. And this one is mg cos theta. And this is opposite to the normal contact force, R. So this would be mg cos theta would be 10m cos 35. 10m cos 35. And this one is going to be 10m sine 35. Achha. Now there's also friction on the surface. That means we also have to point mu r. The formula for friction is mu r. So we also have to point mu r opposite to the direction of the motion. अच्छा, now the thing is कि हमें नहीं पता कि ये m है क्या. What is this mass of block P? अगर ये greater than 5 है, so then it will move down the plane. But if it is less than 5, then it will move up the plane. So हमने दोनों cases देखने. That's why it says find the set of values of m for which the two blocks remain at rest. Okay, so let's say that if m is, if mass of P is less than 5, if m is less than 5, then P is going to go downwards. I'm sorry, upwards. Because Q will go downwards. Q is going to go downwards and P is going to go upwards. Okay, if it go upwards, then we have mu r in this direction. And also mg sine theta in this direction. And also t in this direction. And mg cos theta in this direction and r in this direction. Okay, now let's keep the objects at rest and find the equations acting on both the particles or both the blocks. At Q, if it stays at rest, then T should be equals to 50 newtons. Upward force should be equals to downward force. Okay. And at P, if the object stays at rest, then the T upward force should be equals to mu r plus mg sine theta. Okay, T we already know is 50. Mu is 0.2. R is equals to mg cos theta. These two forces are in equilibrium. So they're equal. So m is m, g is 10, and cos 35. Plus 10m sine 35. Now take m common at the right hand side and divide the rest with 50. So I'm going to take m common. So I have 0.2 into 10 into cos 35 plus 10 sine 35. Now take the bracket to the other side and it gets divided by 50. So what do we get for M? It says it should be 6.78. आता है? Do we get
Yes,
that?
ma'am.
Okay. 6.7805 मेरे पास लिखा हुआ है. I don't have a calculator today, but that is what the answer says. बाकियों का भी यही आ रहा है, आयशा?
जी हाँ.
Okay. So now we're going to assume that if M is greater than 5, that is the weight of P is greater than the weight of Q, then P should be moving downwards. So then this block P should be moving downwards. So then the friction should be in the opposite direction, mu R. Also, there's tension in this direction since the rope is upwards, and the only downward force is going to be mg sine theta. And we still have the cost component of weight here, and we still have the normal contact force, right? Okay. So the force at Q is going to stay the same, although now Q will be going upwards. Q will be going upwards. So the forward force is T is equals to the backward force is 50. So it's still 50 is equals to T because the object is at rest. This is at Q. So at P, we're going to say forward is equals to backward. So mg sine theta equals T plus mu R. So 10m sine 35 is equals to T plus mu is 0.2 and R is 10m cos 35 and T is also 50. This is 50. Okay. So I am going to rearrange 10m sine 35 minus 0.2 into 10m cos 35 equals to 50. Now again you take m common and we have 10 sine 35 minus 0.2 into 10 into cos 35. Take this to the other side, divide it with 50. Okay. So m comes out to be it should be 12.2 according to the answer. So your final answer would be mass is between 12.2 and 6.7805. If your mass of P stays within this domain, then the objects stay at rest. Okay, since the object had to be kept at rest, so we did forward force is equals to backward force. We did not do forward minus backward is equals to ma because acceleration is 0. Okay, moving on to the next question. I just realized मैंने 2-3 क्वेश्चन स्किप करा के क्वेश्चन 18 करा दिए. I did not do 16 and 17. चलो वो बाद में कर लेते हैं, अभी 19 करते हैं, then I'll go back to the previous questions. Okay. Today is the last day we're spending on connected particles. कल हम करेंगे power and energy, work power and energy, third last topic, and then the second last topic, kinematics, and then the last topic's momentum. We should be done by the end of the month. Okay. Smooth inclined plane of length 2.5 meters is fixed with one end on the horizontal floor and the other end at a height of 0.7 above the floor. P and Q have a mass of 0.5 and 0.1 kgs respectively and are attached to the ends of a light inextensible string which passes over a smooth pulley fixed at top of the plane. Particle Q is held at rest on the floor vertically below the pulley. String is taut and P is at rest on the plane. Q is released and start to move vertically upward towards the pulley and P moves down the plane. Find the tension in the string and the magnitude of acceleration of the particle before Q reaches the pulley. Okay, so we have to form two equations, one on P and one on Q, and solve them simultaneously to find A and T. Okay, so Q is going upwards, so it's going to have a forward force of T and a backward force of, what's the mass of Q? 0.1 kg. So mg will be 1 Newton. So at Q, the equation is going to be forward force minus backward force is equals to ma. This would be equation 1. Okay. Then at P, we have a forward force. Since P is going downwards, there's a forward force which is going to be the weight component mg sine theta. Then there's mg cos theta here. There's R here, and then there's T here. There is no friction mentioned in the question. Then we don't use the mu R component of the friction. Okay, so now at P, the forward force is mg sine theta minus backward force T is equals to ma. So ma for P is 0.5. So 0.5 times 10 is going to be 5 sine theta minus t is equals to 0.5a. Now I need sine theta. So I will use the triangle given. There's a right angle given. This is the theta. We need hypotenuse is 2.5, opposite is 0.7. So sine theta is going to be opposite over hypotenuse. So then this would be 5 times 0.7 over 2.5 minus t equals 0.5a. Simplify this, we get 1.4 minus t is equals to 0.5a. This is the second equation. Solve these two equations simultaneously to get the value of t and a. T should come out to be 1.07 and a should come out to be 2 by 3. Can you please check?
मैम वैल्यूज क्या बननी चाहिए ए की टू
एक ही,
बाई
हाँ जी 2/3 और टी
जी
की 1.07
हाँ,
आ रही है।
एक ही तो आ गई है। ठीक है, भी देखता हूँ।
ओके।
जी मैम, 1.067 आ रहा है।
ओके, सो राउंडेड ऑफ इज दिस। ऑलराइट, ठीक है, नेक्स्ट पार्ट देखते हैं। आई होप others got the same answer as well. Next part is, at the instant just before Q reaches the pulley, the string breaks. P continues to move down the plane and reaches the floor with the speed of 2. Find the length of the string. Okay. So it says that as soon as Q reaches the pulley, the string breaks. So when Q reaches the pulley, that means it covers this distance as Q reaches the pulley. So now Q is right at this point. It's about to hit the pulley. Okay, so it covers a distance of 0.7 meters. So that means P will also go down a distance of 0.7 meters. Okay. And we can find the speed at this point, right before Q hits the pulley, and that will be the same speed of P at this instant. Because the particles are connected, they have the same speed at a particular instant. Okay, so for Q, we know that its U is 0, the initial speed. Its final speed is what we're trying to find. Its S is 0.7 meters, and the acceleration found in the last part is 2/3. So now we need to use equations of motion to get V. Which equation of motion should I use? You have U, V, S, and A. Which equation of motion uses these four values?
V square is equals to U square plus 2as.
Yes, V square equals U square plus 2AS. So V is going to be square root of 0 square plus 2, 2/3. S is 0.7. So V comes out to be, say, 0.966091 meters per second. Okay. That means that the speed of P at this point is also the same. This is going to be U is equals to 0.96. What did we get? 66091. Okay. So now we need the distance of the rest of the journey of P falling down. Okay. What do we know about this part of the journey? We're told that the speed of P when it reaches the ground is 2. So the final speed here is going to be 2. Let's call it V is equals to 2. So for the blue part of the journey, we know U is 0.966091. We know V is 2. Okay. Now the acceleration is not going to be the same acceleration anymore, because when P hits, when Q hits this point, the string breaks. And now the string has broken. So that means there's no tension in the string anymore. So forward force is now 0. So forward minus backward is equals to acceleration. The acceleration is going to change. Forward force minus backward force is equals to ma. So since the forward force has changed, the acceleration will also change. So now the string is broken. So there is no force at the back. So यहाँ पे था, string was at the other end. So P is falling down, but there's no force over here. T is equals to 0 because the string has broken. There's a force over here, which is mg sine theta. So forward force is going to be mg sine theta minus backward force is now 0 is equals to ma. So m and m can be cancelled. 10 into what was our sine theta? It was 0.7 over 2.5. This should give A. Which comes out to be it says 2.8. Can you confirm? Acceleration should be 2.8. आता है 2.8 यहाँ से?
Yes, ma'am.
Okay. So acceleration is 2.8 और बाकी तो हमें पता ही है कि V was 2, U was 0.966091 और A भी अब पता चल गई 2 point. So now we can find S, the distance of the blue part. So we can use V square is equals to U square plus 2S again. So V square minus U square over 2A should give you S. So 2 square minus 0.966091 square over 2 times A is 2.8. Which gives S equals 0.5476. Okay. So the the length of the blue part of the slope is 0.5476. ठीक है, एक ब्लू पार्ट है, उसके बाद एक ग्रीन पार्ट है, वो तो हमने देख लिया था 0.7 है, और उसके ऊपर भी कोई पार्ट है, इसको पिंक कर लेते हैं. And the combined sum of these three parts is 2.5 because the entire slope is 2.5 meters. Okay. The blue part had come out to be 0.5476 and the green part was 0.7 and the pink part is, we don't know that. तो पहले वो फाइंड कर लेते हैं. पिंक पार्ट की लेंथ वो ये आ जाएगी और उसमें जब 0.47 ऐड कर देंगे तो स्ट्रिंग की लेंथ आ जाएगी because we need the length of the string eventually. So I'm going to do 2.5 minus 0.5476 minus 0.7 equals x. ये बताना क्या आता है? What is 2.5 minus 0.5476 minus 0.7?
It's 1.2524.
1.2524.
24, ओके। तो अब पूरे स्ट्रिंग की लेंथ चाहिए, तो इसमें इसकी लेंथ और इसमें 0.7 ऐड करेंगे। सो लेंथ ऑफ स्ट्रिंग वुड बी 0.7 plus 1.2524, which gives 1.95 after rounding. Okay, let's do one more question from this worksheet and then start the paper. Okay. लेमीज थ्योरम का ही मैं एक और क्वेश्चन करा रही हूँ, जैसा एक क्वेश्चन हमने कल भी किया था। So we're doing question number 17. अच्छा, see, you'll have three forces acting on x only. एक इस डायरेक्शन में, एक इस डायरेक्शन में और एक नीचे की तरफ। That means हम लेमीज थ्योरम यूज कर सकते हैं। Let's quickly revise लेमीज थ्योरम क्या है, कल भी देखा था। Let's say this is force T1 and this is force, let's say T2, और यहाँ नीचे कोई और फोर्स है, फॉर एग्जाम्पल वेट। So then what you need is this angle opposite to T1. So उसको हम कह देंगे T1 over sine theta 1. Then is equals to T2 over the sine of the opposite angle to T2. So it's going to be T2 over sine theta 2. And then weight over, let's say this is the angle opposite to the weight. So let's call it theta 3. So weight over sine theta 3. दैट इज लेमीज थ्योरम। इसका फायदा ये होता है कि आपकी बहुत ज्यादा वर्किंग बच जाती है, वरना तो आपने हर फोर्स को इधर रिजॉल्व करना है। ये इसका वर्टिकल पार्ट है, ये इसका हॉरिजॉन्टल पार्ट है, दूसरे का भी ये वर्टिकल पार्ट है, ये हॉरिजॉन्टल पार्ट है, और फिर उसको इक्वेट करना होता है। एंगल्स चाहिए होंगे इधर। फिर वो तो लेमीज थ्योरम के लिए भी एंगल चाहिए होंगे, बट लेमीज थ्योरम मेक्स योर वर्किंग अ लॉट इजियर, सो इट्स एप्लीकेबल, इट्स बेटर टू अप्लाई इट। Okay, but it only works when you have three forces acting on a point. अब इधर एक और फोर्स आ जाती तो फिर लेमीज थ्योरम नहीं अप्लाई होता, क्योंकि फिर फोर फोर्सेस हो जाती। Okay, so now let's take a look at the question. Wherein diagram shows three particles A, B, and C hanging freely in equilibrium, each being attached to the end of a string. The other ends of the three strings are tied together and are at the point x. अच्छा, ये three strings हैं, so hence three different tensions. एक string ये है, एक string ये है, और एक string ये है। So हर string में अपनी tension होगी। Okay, the other end, अच्छा, the string carrying A and C pass over smooth fixed horizontal pegs P1 and P2. Weight A, B and C are 5.5 newtons. अच्छा, यहाँ का इसका weight है 5.5 newtons. Okay. और बी का वेट है 7.3 न्यूटन्स और सी का वेट है डब्ल्यू, दिस इज डब्ल्यू न्यूटन्स। ओके, अब सिंस देर हैंगिंग इन इक्विलिब्रियम, दैट मीन्स इसको अगर हम T1 कहें तो T1 is equals to 5.5 because the system is at rest. Forward force equals to backward force. इसको कह देते हैं T2. T2 is equals to 7.3 और इसको कह देते हैं टेंशन इन द रूट 3. T3 is equals to W. Okay. Okay. What else? Acha, what we have to find? The angle P1, X and P2 is a right angle, as we can see in the figure. Find the angle AP1 and X. Okay, so we have to find this angle. This angle, let's call it angle X. The angle find करना. Okay, so let's see. Let's apply Lemmy's theorem on point X. Okay, so on X, there's going to be an outward force, which is going to be tension 1 because it's still the same pink string. So T1 की direction इधर outwards होगी. Blue वाली string में T3 की यहाँ outwards होगी away from the point और T2 जो होगा वो downward होगा. So I'm going to do T1, which is 5.5 over sine. यहाँ पे आपको θ1 ड्रॉ करना होगा. यहाँ जरा θ1 ड्रॉ करो. Opposite to T1 is θ1. So over sine θ1. इसको हम बाद में देखते हैं क्या है. Is equals to T2 और T2 के opposite तो 90 डिग्री है. So over sine 90 is equals to T3 over sine T3 के ऑपोजिट ये एंगल कह लेते हैं तो वो θ3 होगा. सो ओवर θ3. यू मस्ट शो टू द एग्जामिनर कि θ1 से आपका मतलब क्या है और θ2 से आपका मतलब क्या है. सो आपकी फिगर में ड्रॉ होना चाहिए θ1 और θ2 θ3. ओके जी. अच्छा, अब T1 की वैल्यू हमें पता है 5.5. सो आई एम राइटिंग 5.5 ओवर हियर. T2 की वैल्यू हमें पता है 7.3 और T3 की वैल्यू हमें पता है W. Okay. So now I can use the first two equations, these two, and get θ1. जैसे θ1 हाँ निकाल के फिर उसको 360 से माइनस करके आ जाएगा. Okay. So या θ3 डायरेक्टली निकाल लेते हैं. Let's use the first and the last equation. इन दोनों को यूज कर लेते हैं, इसको और इसको, and get θ1. θ3, sorry. So 5.5 over sine θ1 is equals to, अच्छा इसमें तो W है तो नहीं यूज हो सकता, इसमें 2 unknowns है. So अभी नहीं आ सकता. So we must use the first equation, first set of equation. 5.5 over sine θ1 is equals to 7.3 over sine 90. इससे पहले θ1 आएगा, वो क्या होता है? θ1 comes out to be, please cross multiply then take sine inverse. क्या आता है θ1? क्या वैल्यू आती है इस एंगल की? You have to do 5.5 into sine 90 over sine 0.3 और फिर उसका sorry 5.5 into sine 90 over sine 5 7.3 और उसका sine inverse. Sine inverse of 5.5 into sine 90 over 7.3. What do you get? Guys, I'm dependent on you for answer because I don't have my calculator. मिल रहा है आंसर कि नहीं मिलेगा? आयशा, जरा
मैम 0.73901.
सॉरी,
0.73901.
आपका फिर मुझे लगता है रेडियंस में है
वो रेट
कैलकुलेट, डिग्री में करो।
48.8
38.8 आता है।
नहीं
48
48.8
48.8.
ओके ओके, सो थीटा 1 आ गया 48.8। अच्छा, अब मुझे इस एंगल को देख के बताओ, ये जो थीटा 1 है एक्स की राइट हैंड साइड पे, क्या ये हो सकता है 48 डिग्रीज? ये वाला एंगल, ये जो एंगल है 48 का मतलब है एक्यूट। इज दिस एन एक्यूट एंगल?
नो
मैम रेट
नहीं है। तो इसमें वो ऐड शुगर टू कॉफी वाले से ना सेकंड वाला एंगल हमें चाहिए, फर्स्ट वाला नहीं चाहिए। क्या होता है, साइन पॉजिटिव फर्स्ट क्वाड्रेंट में, उसका आंसर आपके पास आ गया है 48.8। और साइन पॉजिटिव सेकंड क्वाड्रेंट में आपको ये वाला एंगल चाहिए। ये क्या होगा? 180 माइनस 48.8, विच इज
131.12.
131.12। चलो, अब एक एंगल आ गया है, और एक एंगल हमें ऑलरेडी पता था 90 है, ये 90 है। उसके ये वाला एंगल आ गया है 131। Now let's find θ3, the third angle, from 90 minus, sorry, 360 minus 90 minus 131.12. So 360 minus 90 minus 131.12. What do we get for θ3? 360 minus 90 minus 131.12 से क्या आंसर आता है?
138.88.
138.88। ठीक है, so this angle is 138.88। ओके, अब हमसे क्या कहा गया है? हमें कहा गया है ये एंगल निकाल के बताना है। यहाँ पे एक एंगल बन रहा है, वो निकालना। दिस इज लेट्स से एक्स, ये एंगल निकालना। तो अगर हम इसको एक राइट एंगल बना लें इस तरह से, तो यहाँ पे 90 आ जाएगा। और ये जो रिमेनिंग एंगल है यहाँ पे, दैट वुड बी 138.88 minus 90, because this is 90 as well. So this upper angle is going to be 138.88 minus 90। क्या आता है 138.88 minus 90?
मैम 48.8
48
48.88.
point, okay, 48.8। okay, so now we can find x from 180 minus 90 minus 48.88। तो क्या आता है रिक्वायर्ड एंगल?
41.12.
ठीक है, ओके, ये आ गया x। और फिर उन्होंने कहा फाइंड द वैल्यू ऑफ w। सो w फाइंड करने के लिए हम दोबारा से लेमीज थ्योरम में चले जाते हैं। हमें ये पता है 7.3/sin 90, और अब θ3 भी पता चल गया। सो ऑल दैट्स लेफ्ट टू फाइंड इज w। सो बैक टू लेमीज थ्योरम, 7.3/sin 90 equals to w over sin 138.88। क्या आता है? This should give you the value of w।
4.8.
ठीक है 4.8 न्यूटन is the answer. चलो. That is enough practice of connected particles.